Okay, again, there's questions like 1, 2, 3, 4, 5. And again, if I were looking at these, it's always says which is the easiest question to do. I notice I a lot to go for low-hanging fruit, and that depends on individuals. I would say that sometimes people don't want to do the problems that have a lot of words in it. They're looking for ones with compact symbols in it. So 2 and 3 really, it's the easiest one to look at because there's just math written down there. So this just written down over here, this written over here. All right. The other ones are word problems, and they might be more difficult to understand. Now, number 1, prove there exists an infinite convergent geometric series. I'm looking at number 1. Each member which divided by the sum of all following it equals a given number k. Now again, a lot of people that just see that as alphabet soup. I don't know what to do with it. I want to cut to the chase, though. I'm gonna walk you through what I think you should do if you get stuck. I would try to do the problem first, but I want to point out, just reading it. I'm going to do number 1. I'll talk about the blue area in a second. So prove there exists an infinite a convergent geometric series. So the first thing I do is I just write down what a geometric series looks like. It looks like this. That's an infinite, and that sum would be convergent only if this r, which is called the common ratio, is a proper fraction. And again, a is not equal to 0. Otherwise, all the terms would be 0. All right? So let's see what we're told. We're told that each member of which, right, divided by the sum of all following it. So I want to point out, each member, like, for example, if I did a member over here, so each member, so let's talk about just a member in general, and that would be AR to the N, right? It says each member of which divided by the sum of all the following. Well, the sum of the following guys would be this over here, A, R, and that would be N plus 1, plus A, R, N plus 2, plus yada, yada, yada. They say for each member of which divided by the sum of the following equals some given number K. Right, that's what they said. So I'm looking at that, and I don't like to look at the fraction, so what I did was I just multiplied both sides by the LCD, and this is the LCD over here. And you would get this over here. All right? Then the next thing I would do, let me get my eraser out and erase this business over here. I'm also going to erase this. I'll erase this now. We're just going step by step. The next thing looking at that, I know it looks difficult, but I probably would divide both sides by ARN. So I'm gonna divide, and again we're here. I'm gonna divide both sides by A R to the N. All right, what would you get? On the left side you get 1, and I want to point out, you're dividing every term here by an ARN. All right, so what would you get? Well, gee, the A's would all cancel, right? And each of the exponents would be decreased by N. So you get 1, 2, 3. Yeah, it makes sense. All right, so I followed that, and I'm here. Now, what do I notice about this? I notice that this sum over here, let me write this down for you, that R plus R squared plus R cubed is also geometric. So I'm just going to say, what does that equal? Well, A1 is R, and it's going to be 1 minus the common ratio of R. So that's easy. I can write that down, and that's what that next line is. All right, let me get my eraser out. I'm just going line by line. So I got that. And then I'm looking at this. I wonder what their question is. It says, for what values of K does the problem have a solution? Well, now I got to solve the equation now. I got to figure this out. So what'd you get? You'd get 1 minus R equals KR. Gee, I got to solve for, let's see, they got to find the K, right? I know something about R. I want to point what I mean by that. I know something about R, but I don't know anything about K at this point. So I guess what I want to do is solve it for R. Let's put this down. So let me write this down. 1, whoops, sorry about that. 1 I did it again. Get my eraser again. So 1 would equal KR plus R. And again, I know something about R, so I'm really trying to figure this out now. So R, K plus 1, which would be 1 over K plus 1 equals R. All right, this is an important fact over here. Now, Grant, I understand people get stuck sometimes. So why would I have done that? Well, I know what R is, all right? So what does R have to be? I'll write this over here. R has to be this. Well, R is actually just this. And I did that right over here. That's got to be this, all right? So now I'm in a problem now that it's getting a little more familiar to me. There's all this business over here. Just going step by step. I'm walking you through my typeset work here. I'm right here now. Now, can I solve that inequality? I think I can. I want to point out what I mean by that. This is just, right, if I just look at that, it's 1 plus K. The absolute value would have to be greater than 1. All right, let's keep going. And what does this mean? It's an absolute value inequality. So 1 plus K greater than 1, or 1 plus K would have to be less than minus 1. Let's keep going. K greater than 0, or K is less than minus 2. I'm going to put a number line down, see if I can visualize this. I got two numbers, 0 and minus 2, and K could be greater than 0 over here. And the other thing K could be is it could be less than minus 2 over here. So K has got to be on this interval between minus infinity to minus 2, union 0 to infinity. Right? It wasn't that bad of a problem. It's a struggle, though. I just walked you through my work. And do they write that down? Yep, right over here. They didn't put the intervals down, though. Now I'm going to look at number 2. And again, I'm walking you through the work. I got to be honest with you, looking at this, it doesn't look easy to do. But again, I'm assured that if they're asking me, they're probably convinced that I can do it. So what I would do looking at the problem is, I really, and this is just me, this may not be you, but I'd write it as fractional powers. So I'd write this as 3/4, and then plus 2x to the 1/2 minus x to the 1. Now, so you don't have to put that down, but I'd like to do that. I'm going to write things in terms of the same, fraction. So 3/4, LCD, so to speak. 2x to the 2/4. And again, when you're doing this over here, it may go nowhere. And then what I'm looking to do is I'm looking to factor the problem. All right, and by the way, when I do that, that could be a tough thing to do, by the way. I'm kind of looking at it. It looks a little backwards to me, though. I'll tell you why. I want to put the biggest number up front. And then what will come next then? 3/4, right? I'm just putting it in order because this is what I've done in algebra, right? So what I tell my students in algebra, I tell them that we really don't like to have a leading coefficient of negative. And since I'm assuming it's factorable, I would like to get that to be the number 1. So what I'm going to factor out, I'm going to factor out minus x to the 2/4. And let's see what we come up with. Well, you would get x, let's see what you get. That would be 2/4, right? Plus x, well, I'm not plus, it's minus, isn't it? Factor out a minus sign. Sorry about that. We'll check it too. X to the 1/4 And then I get what? Minus 2. All right, let me simplify this a little tiny bit. It's going to be minus the root of x. Oh boy, this is going to be what? Looks like it might be factorable. X to the 1/4. Whatever I put down, I'm going to check it. X to the 1/4. I would say 2 and 1. Looks like minus plus. And is that going to work? Well, x to the quarter times x to the quarter is x to the 2/4. That works. And then you get minus 2 x to the quarter plus x to the quarter, which would be minus, yeah, it works out beautiful. So what do I got? Let's write this down a little differently. Minus root x. This is the 4th root of x plus 1. And this would be the 4th root of x minus 2 equals 0. Now what's their question? Their question is solve for x on the real numbers. So x could be 0. That's this one over here. This has no real solution, but this has a real solution over here. What would that be? Well, 16. The 4th root of 16 is 2, and 2 minus 2 is 0. So I get 2 answers, 0 and 16. You can, of course, check that in the original expression if you want, right over here. All right, let's go to number 3. Now, looking at number 3, I want to point out that's a tough question. Like, if you try to integrate this, again, I'm not going to say things are impossible, but it's highly unlikely. I'm looking at e to the x squared, and I mean, I guess you could get some kind of general statement down about this thing, something to do with the error function, but it just doesn't look reasonable to me. So what I want to do, I want to write down y equals e to the x squared. All right. So what I'm going to do is I'm going to use the log to rewrite it, and you're going to get ln y equals x squared. Then I'd probably say x. I gotta be really careful about this, and I got to be really careful now. And what I mean by that over there, looking at the original problem, I know the x values are between 0 and 1, so we're talking about no negative numbers. So I'm pretty safe in saying this. Whoops, sorry about that. Well, once I do that, I start to realize I'm seeing inverses. In other words, if f of x equals e to the x squared and its domain is between 0 and 1, its range would be, let's say, e to the 0 would be 1e. Its inverse, and again, by pure chance I found it, what do you get over here? It would be the root of the natural log of x, where its domain is 1 to e, and its range is going to be 0 to 1. All right? So I'm looking at these guys, and again, it might have been pure chance because I was trying to see something, and then all of a sudden you see an inverse. And what do I notice about this over here? Well, look at these limits here. I'm going to make some crude attempt at graphing this, but I know they're inverses. A crude attempt. So let's graph this guy first. I'll do that in red. So at 0, it would be 1. And then when I get the 1, it would be at E. Now, I kind of, It's up here somewhere. And this is crude, I know that. But I'm going to say something like this. And I'm going to shade it in now. And this is the area they're talking about. I'm going to graph the inverse in, which is much more difficult to deal with. But I do know since it's a rotation of that curve. I'm going to be careful here. And I'm going to do that in blue. So I'm going to graph this guy over here. So the first point would be 1, 0. You get the idea? I'm just doing the first point. And the last point would be 1e. So I hope you realize what we're saying over here. It's kind of like a rotation. And that's going to be E1, I'm sorry. It's a rotation of the point. Let me get my eraser. It doesn't look right. E1. Something like this. And I'm going to get my little shader out, shade that in now. Oops, shader. Now I'm going to get my pen out, and I'm going to do it in black. I'm looking at this region here. That's going to be a tough computation, isn't it? And this region over here. What I noticed, though, looking at it, is if you took this region here, you could actually just pop it in right here. Again, I'm looking at that symmetry. So really the whole area they're talking about is this guy right over here. Let's see if we can compute that. Right, so we're just doing an area, seeing it. So what's the base of that? The base appears to be 1. And what's the height of that? Just a. So this integration turns out to be a. All right. Now, by the way, I want to point out, I did do a rough graph. It's really not great. And I did a better graph over here. And I hope you realize this is a much better graph than the one I gave you. All right, much better graph. At this point over here is going to be 0, 1. This point over here, just a rotation, so it's going to be 1, 0. By the way, this line y equals x. This point over here, again, I want to point out we did that before. And that was E1. And this point over here is 1, comma a. All right? I hope you're looking at this much better picture. And it's really nice to have good pictures, by the way. That if you took this one over here, popped it in here, you'd fill up that entire space over here. What's the base of this thing over here? It's 1 unit. What's the height of this thing over here? A. So the A, it's pretty reasonable. Again, if you try to integrate that guy, I think it would be a really, really difficult problem to do. All right? Again, some of you may prove me wrong, but I think it would be a difficult problem to do. All right, this one over here, 4, it says a sequence of numbers, x1, x2, up to x100, has a property that for every integer k between 1 and 100, the number xk is 1 less than the sum of the other 99 numbers. So let me write this down for you. x1 plus x2 plus x3 plus yada, 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 all the way up to x100. All right? So let's see if we can understand just one simple statement out of it. So it says, has a property that for every integer k between 1 and 100, the number xk, well, let's do x1, is k less than the sum. So I'd have to do x1, the sum of the remaining other terms. That would be x2 plus x3 plus yada, 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 up to x100. So I think I could write a bunch of these things down, and let me point out what I mean by that. I've got this one written down. Now, if you did x2, it's going to be x2 plus 2, and of the sum, x2 would be missing. Right? Not that I'm going to write this down, but if you wrote down x3 plus 3, it would be x1 plus x2 plus x4 plus yada, 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 up to x100. All right? You get the idea what I'm doing, right? Now, I'm going to write them all down, and that's why I put these dots here. And if you got the x50, what would you get? x1 through x49. You have to skip over x50, and then 51 through 100. If you did 51, what do you get? x1 through 50, and 51 is going to be left out, and then 50 to 100. And then you keep going. I know it's tough. I'm just writing down some patterns. x99 plus 99 would be x1 through 98. 99 would be missing, and then x100. x100 is 1 through 99. All right? So in general, they say this is what in general looks like. All right? What are they doing? They're summarizing what we see up here and making a general statement. All right? So now comes a tough problem. You've got to read it. I want to see if there's anything I missed over here. Sequence of numbers, blah, blah, blah. Fringe K, I got that part covered. Given x50 equals m over n, where m and n are relatively prime positive integers. So let me make sure you know what that means. x50 is a fraction where m and n are rational numbers in lowest terms. They're positive too. All right, so what are we going to do now? We're going to look at it. And I'm kind of looking at it. And let's take a look at what we're going to do now. Well, I'm kind of looking at this statement here. And I'm going to add xk to both sides. And if you did that, if you add xk to both sides, right, you would get 2xk plus k would equal the sum x1. And now xk is not missing from this side, so it's going to be x2 plus everything up to x100. Right? That's the sum. Now that's what I wrote over here. Okay? So now I got troubles. Kind of looking at it. And let's take a look here. Well, you know what I'm going to do? I'm going to look at all these equations. Well, that's not bad. If I add them all together, I still want to get the same pattern. So I'm going to say 2x1 plus 1 would now equal that sum. I'm going to call that sum. Let's see, n equals 1 to 100 of x. Let me make an I here, okay? Let me get my eraser out. Call it J instead. I don't like using I. Like J equals 1, and now it would be xj. And what's the next one going to be? It would be 2x2 plus 2 would equal that thing. And then 2x3 plus 3 would equal that thing. You get the idea? All right, I keep going, right? So I'm thinking I could just add them all together. Right, add them all together. And what would you get? Let's keep going over here. So, you know, if I get, let me just go dot, dot, let me go to the end. So it's going to be 2x 100 plus 100 equals the same sum, right? So then the question is, how many, if I add them all together, that'll be 100 of those things, right? There's 100, all right? So I'm going to outline that where you see that over here. I see 100, but I'm using a K and a J over there. And then I'm looking at this over here, and if I add these together, that's going to be the sum of the integers from 1 to 100, all right? And that's written right over here. And this is going to be the sum. Well, that's going to be twice the sum of x1 through x100. And that's why that's written over here. Okay? So I got some troubles now. I'm looking at this thing. I got three different sums to deal with. But I do want to point out that this sum here is identical to this sum here, except for the coefficient. So I'm going to subtract from both sides. And what do you get? The sum, k, equals 1 to 100. K, we'll do that later. That's one sum I can do. And the other one's going to be 98 times the sum, k equals 1 to 100 of xk. This is easy to do. That's the sum of integers from 1 to 100. So it's going to be, and I certainly hope you know the formula there. It's 100 times 101 over 2. And that equals 98 times the sum, k equals 1 to 100, xk. Well, let's take a look at this, right? I guess I have to do something, don't I? I guess I'm going to divide by 98. Let me just do this first. 2 goes into 2 once, goes into this 50 times. And I'm going to divide both sides by 98. And what is that going to give you? Well, I'm going to divide by 2 again. So it's going to give you 49, and this will give you 25. So you get 25 times 101 over 49 is equal to the sum, k equals 1 to 100, x k. All right? So let's go back and get the question. All right? Because I'm, as you might see at the dead end right now, so it's given that x50 equals m over n, where m and m are relatively prime positive integers, m and n. All right? What do they want me to find, though? Oh, find m plus n. Well, that's going to be a tough one, huh? So let's take a look. And we got this relationship over here. I'm going to put a little thing over here. And let's write this down. So 2x50 plus 50 is going to equal, right? Remember we talked about this before, right? Right? 2x50 plus 50 is just going to equal this thing over here. And what's that going to be? 25 times 101 over 49. I got some work on my hands, don't I? And let's write this down. x50 equals 25 times 101 over 49 minus 50. Hope I'm not going too fast. Oops, there's 2 over here too, right? I'm going to divide both sides by 2. x50 equals 25, 101, 98 minus 25. Now I want to remind you again, this is m divided by n in lowest terms. I got troubles, by the way. I'll tell you what the troubles are. I got to do some arithmetic now. And I really don't enjoy doing the arithmetic, but I got to do it. I don't have much of a choice. And so let me do 25 times 101. That's going to be 25, because 1 times 25 is 25, and then 2,500, right? That's 5252. Let me write that down for you. 2525 over 98. And now I got to do minus 25 times 98. Well, let's see. 5 times 8 is 40. And let's see. 5 times 9 is 45, 49. 2 times 8 is 16. 2 times 9 is 18, 19. 0, 15, 14, 2450. I got some more work to do, don't I? And again, this is x50, which is equal to m over n in lowest terms. So 25, 25, and that's going to be 50, 75, right? Let's make sure I did that right. Yeah, 75, 98. All right, 75 over 98. Can that be reduced? Well, let me write this down for you. 75. Well, that's going to be what? 5 times 15, which is going to be 5 squared times 3. Well, you know what? I know the bottom number is certainly not divided by 5, and it's not divided by 3. So now I know what m and n is. M is 75, and n is 98. So m plus n is 75 plus 98, which is going to be 173. Let's see how we did. We got it right over here. So let's just see what we've done so far. And I always say that, they're not easy questions. I know that. So I think we've done quite a bit. I mean, I think I started with number 1, right? Yeah, I started with number 1, went to number 2, we did number 3. Yeah, that's a tough one, 3. 4, we just did. That was awful tough. And now we're going to go to number 5, all right? So it says, for how many ordered pairs x, y's of integers is it true that the arithmetic mean of x and y? Well, the arithmetic mean of x and y is x plus y over 2 is exactly 2 more than the geometric mean. So is exactly 2 more than the geometric mean. Well, the geometric mean between x and y is x times y, and it's going to be the root of that. So it's going to be plus the root of xy. All right, a little tough question, isn't it? And I got this over here, and I see that. Let me get my eraser out. I'm kind of done with this business. And I'm starting here. I read it, I start there. So I'll read that again and make sure. How many ordered pairs x, y have oh, now they give me this is a good key word here. So they're integers. So I know x and y are integers. I'm going to multiply both sides by 2. Now what? Well, when I was in math, basic math class, I always say isolate the radical and then square both sides. Let's see if that helps out. If you square both sides, I'm not going to bore you with the detail, but I'll say if you do square the left side, I'm hoping you're able to get this over here. It looks like it's getting worse, doesn't it? Remember, these are integers, though. And I guess I kind of put it in order, right? And so, x squared, I took away 4xy from both sides. I see this, which is a perfect square. Let me tell you what I'm doing over here. Again, I did not do this for you. I was expecting maybe you can do that yourself. Well, let me write this down, though. If you do expand it, you get x squared plus y squared plus 2xy minus 8x minus 8y plus 16, and that equals 4xy. I would subtract 4xy from both sides. You get x squared plus y squared minus 4xy minus 8x minus 8y plus 16 is equal to 0. What do I notice immediately over here? I'm sorry, I said I subtracted 4xy. It's minus 2xy. I made a mistake there. All right, this is a perfect square. It's going to be x minus y squared, and then I'm looking at the other side, and when I say this side of that expression over here, and I don't know, I can put it on the right side. And what would you get? 8x plus 8y minus 16. Let me keep writing this down for you. X minus y squared is equal to 8x plus y minus 2. Right, so we're over here now. Now, I gotta be honest with you. This is where things can get extremely difficult. Right, we know they're integers, by the way, and looking at it, I hope you realize that some things you're looking at are numbers. All right, so I'm gonna say one of the easiest thing to do is that's an 8, right? And it would be nice if this was also like an 8 squared, and this was also 8 over here. All right? For that to occur, x minus y would have to be 8. Right? X minus y would have to be 8. And the x plus y minus 2 would also have to be 8. So what am I saying is, really, if x minus y is equal to 8, I'm just saying that those two numbers, they both have to be 8. All right? Now, someone says, when would that occur? Well, that's where things get really tough. Really tough. I'm going to say 9 and 1. All right, let me go through that with you. 9 minus 1 squared is equal to 8. 9 minus 1 minus 2. Let me see if I did that right. Oh, 9. I'm sorry. I copied wrong. So 9 minus 1 is 8 squared. This is 8. N times 8. Yeah, this works good. All right. Now, the other possibility, looking at it, I want to get perfect squares, by the way. And I'm going to say, maybe, making this a perfect square. And again, there's a factor 8 over here. I guess if I multiply it by 4. All right. Now, what would that mean? X minus y is 4. I see that written over here. And so, 2 times... Oh, boy. I got to do something else, don't I? X minus y is 4. And then I got to do this thing over here. This would be 4 times 2, x plus y minus 2. And that's where this is coming over here. And kind of looking at that, when does that occur? And there's always a play with that, isn't it? So I'm saying 4 and y is 0. Let's see if that works. 4. Yeah, it works. 4, 0 works. So forth and so on. I want to point out there's other ones that are non-integers that also work. I would not be worried too much about that. But we found them right over here. And again, I think that's done. All right. So if we're me in a paper, I'd be honest with you, 5 would be the most difficult one for me. And one is I always find integer solutions to problems be completely vexing at times. And I think probably because I'm a little bit weak at arithmetic. And that's why I find them so vexing. I have to think and stuff. Other people are incredibly quick with numbers. I'm not. So what I claim over here is that I think that was the toughest one. And I really do believe that. I think the toughest problem I have. And so I'm going to say, if you found it tough, that's okay. You get something written down. Maybe you couldn't do the whole thing. But here's the deal. You remember this. You're competing against other people. If you're having a tough time, other people have a tough time. Write something down. All right? Like if this is the only thing that you've written down, at least a grader would say they've got this written down. And if you kind of went forward and you weren't able to do the cases, at least you got something down you can analyze. And this would be nice to get down too, something you can analyze. All right? But if you can't get to this thing with taking numbers out and convincing yourself what the answers are, that's a problem. Right? If you have a different way of doing it, that's also something that a grader might find interesting too. Again, if you need to reach out to me, my name is Bannon. My email address is Bannon, B as in boy, the @ symbol, NNON.US. Again, I want to warn you, I don't think these videos are ever going to become popular, But if I'm getting like hundreds of emails a day from people, I can't answer them. I just can't do it. But if one or two people are answering me, I could probably answer you. All right? If you see something wrong, let me know it's wrong. If I said something wrong, I do it all the time, by the way, I misspeak. Don't get in a bunch about it, but you may want to reach out to me if I said something really egregious. If you see something better, though, that would be nice. Say, I got a better way. And you could type it up or whatever and share it with me, all right? Or post a video, whatever you think is best. But I do want to encourage you to reach out to me. If it doesn't overwhelm me, I'll certainly get back to you. Thank you for paying attention.